So here we've got a C# example of one application. The source for this is on my GitHub account. In this case, we're going to posit that we have a customer who is manufacturing a high-speed transmission system that can produce a 10-bit test pattern. But there's some process problems that can cause failure in that signal. The manufacturing staff has noted that certain patterns are associated with certain process problems. For instance, some patterns are more common when the clock is early, and some are more common when the clock is late. The customer would like to be able to use the patterns to infer information about the process problems. You can see that in this image, where we've got a rising edge here, if the clock rise comes a little bit early, we would not catch that rising edge necessarily. So what is a 1 here is actually going to come through as a 0. So we can see that certain patterns might be associated with certain characteristics of the clock. Now we're going to switch over to the program itself here, which is running in our under Visual C#, Visual Studio. So the first thing we're going to do is generate the nominal series. And up here you see the waveform. So you've got a rising edge, falling edge, rising edge, falling edge. And then here we can see that this is the pattern, and we generated 100 instances of it. And as we expect for the nominal case, all 100 instances produce the same pattern. Now when I click this, it's going to generate 100 instances of an early and 100 instances of a late. Each of these 100 instances, the clock is going to be have a skew that follows a normal distribution. And each instance itself has a number associated with it between 0 and 50, which corresponds to the standard deviation that will be applied to each of the randomizations for the clock events that will occur in this. So when we do this, we can see, let's make that a little bigger. So we're looking down here through here, and we can see in this area here, we've got a particular pattern which is occurring more than others. This pattern is occurring 35 times. Over here, we can also see that certain patterns occur more than others. And let's see, we've got 6. Oh, here it is, 73 times for that one. So we already can see that initially, at least just based on a histogram, that late times are associated with a particular pattern more often as are earlier times. So now when we click this, it's going to train a Bayes classifier. And this uses a naive Bayes classifier, which is also used in junk mail detection, which uses the independent probability of a group of events to predict an outcome. So we're looking at the independent probability that any of these individual clock edges is going to be wrong. Now when we do this, it's created the classifier, and it's done a first pass to tell us how good this classifier is. And an easy way to determine whether a classifier is good or not, at least at first shot, is to feed your training data back into it and see if it comes out with a reasonable guess, reasonable estimate. Presumably, if you train the data train the algorithm against a set of data, it should be able to do a good job of sending that out again. So when we put in the nominal pattern, we see it did a good job of giving us the nominal result, which is what we want. Also, we see for the late pattern, it's done a pretty good job of reporting it late as well. Early pattern is not done very well. In fact, it's almost evenly split between the three. Because presumably this would be a symmetric process, we would want to take a look at the pattern maybe. If we were doing some more work on this, we'd want to understand why the early case is not detected as often. And when we click test, this trial here was done with our training data. This is going to regenerate late and early data and then reapply it to the Bayes algorithm. And it's going to tell us what kind of classification to get. So here we see, again, for our test data, we've got good correlation. And again, here we see for our late data, we also have good correlation. And again, for our early data, it's not so good. So at least we've got a Bayes classifier here, a naive Bayes classifier, and we're able to demonstrate that for a range of nominal and late data, we can classify it well, and not so good for the early data.